Alright, hello. Today we're going to be going over the 2014 Calculus AB FRQ question number 3. So the first question asks us to find what the value of g of 3 is. Well, we can rewrite g of 3 as the integral from -3 to 3 because that's what we plug in x as, and we can plug in 3 to x into this integral. So this is what it would look like. Okay, so now what does this mean? Well, an integral is essentially the area under this function. So we can mark -3 and 3 here, and that is where we're finding the area of. So how do we find the area of this? Well, we know that there's parts of this function that constitute of triangles. So let's get started. So the first triangle here is this part. So we can calculate it with a simple triangular formula. We can write 1/2 base times height. So the base here would be 3 and the height here would be 4. Okay, now let's find this part of the triangle. And we can write this as 1/2 times base times height again. So the base would be 2 and the height would also be 4. And for the last triangle, which is here, well, let's find out. So first, we have to write this triangle as negative because it's under the x-axis, so it is essentially negative area. So let's write that. And we know that the base is from 2 to 3, so it's 1. So what is the height, though? Well, the height, we don't know the y value, so we have to find it. So how do we do that? Well, essentially, this line here is straight, so we can just find 2 points. We can take this point right here, which is 2, 0, and use the given point 4, -4. So we can find the equation of this line and plug in 3 to find the y value. So we can use y2 minus y1 over x2 minus x1, which would lead to -4 over 2x, which is 2, and then the y-intercept is 4, as you can see. So when you plug in 3, y of 3 equals to -2. So the height is 2, so we can write this as this. And finally, we can add all of this up, which would be 6 plus 4 minus 1 equals 9, and that is your answer. Okay, so now for the second part, we're asked to find when g is both increasing and concave down. So how do we do this? Well, we know that the graph of g is this part, this integral, and we have to find when it's increasing and concave down, so we can set some conditions. So first, what does it mean by it's increasing in terms of mathematical context? Well, if it's increasing, then that means its derivative is positive. So we can write that g prime of x is greater than 0, right? So what about concave down? Well, concave down mathematically would just mean that its second derivative is negative, okay? So let's simplify both of these in terms of f, because f is the only thing that we're given as a visual graph. So we can find the derivative of g of x. So let's do that. So the derivative of the integral of f of t. Okay, so let's first do the integral inside. So this would equate to the derivative of big f of x minus big F of -3. Okay, so we take the integral of that, and now we derive this whole thing. So what is this? The derivative of this big F would just mean back to original F, and the derivative of this would just be 0 because the derivative of constant is 0. So we can essentially rewrite this as f of x is greater than 0. Okay, what about g double prime of x? Well, g double prime of x is basically just f prime of x, because we know that g prime of x is f of x, so g double prime would just be f prime since we take one derivative. Okay, so now let's find where on this graph satisfies these conditions. Okay, so we know that on this graph, where is f of x greater than 0? Well, that means that it's positive. So we know that this part and this part, these two brackets are greater than 0, okay? So these are our intervals for now that satisfy this first condition. So what about the second condition where f prime of x is less than 0? Well, this means that its derivative is negative. So that means that the slope is negative. So where's the slope negative? Well, again, this part, the slope is negative, right? And this part all the way to here, the slope is negative. So where on this graph does it satisfy both conditions? Well, we can see that this part satisfies and this part also satisfies because it's under this part, right? So since this satisfies both, we can consider them the intervals. So the interval would go from -5 to -3, and the second part would go from 0 to 2. And that is your interval of where it's both increasing and concave down. Okay, so for the third part, we have to find h prime of 3, and h of x is defined by the circled function. So how do we do that? Well, we can derive h of x first by using the formula to derive division functions. So, we can substitute this. So h prime of x would equal to, we can use the formula, so we can square the bottom, and then we can do low d high minus high d low, and the derivative of the bottom would just be 5. So now we have the formula for h prime of x, so we can just plug in 3. So this would equal to 15 times g prime of 3 minus g of 3 times 5 over, we can simplify this to 5 times 3, which is 15, and 15 squared is 225. So now what? Well, on the last problem, we found that g prime of 3, last time we found that g prime of 3 is basically just f of 3. So f of 3 is just -2. So this would equal to 15 times -2, which is -30, minus 5 times g of 3. So what's g of 3? Well, g of 3 we figured out in the first problem, which is 9. So minus 9 times 5 is 45. So now we have the arithmetic. So we can simplify this to -75 over 225, which is equal to -1/3. And that is your answer. Okay, so for the last part, we have to find what the slope of the tangent line to the graph of p at the point -1 is. Okay, so what does this mean? Well, first we know that p of x is defined by f of x squared minus x. So what does it mean when it says the slope of the line tangent to the graph of p? So that means its derivative. So we can rewrite this question as p prime, right? P prime of -1. So how do we do that? Well, we can first find what p prime of x is. P prime of x, we can use the chain rule. Let's first derive f directly and multiply the derivative inside, which is 2x minus 1. Okay, so now what? Well, we can plug in -1 equals to f prime of 1 minus -1, which is 2, and then 2 times -1, which is -1, minus 1 is -3. Okay, so what is f prime of 2? Well, f prime of 2 is just the slope at 2, right? Because it's the derivative. And we already figured out that the slope of this straight line in the first problem was -2. So we can replace this with -2 times -3, and your final answer for p prime of 1 is 6.